Hello everyone. Today I will be teaching you how to identify similar triangles using the angle-angle similarity postulate and the side-angle-side and side-side-side similarity theorems. We have already learned some shortcuts similar to these to show that two triangles are congruent to each other. Now we'll be applying some of these to similar triangles. Our first one is the angle-angle similarity postulate. You can abbreviate it AA. What it says is that if you have two angles of one triangle that are congruent to two angles of another triangle, you can conclude that the triangles are similar. Think about it. If you know that angle A and X are congruent, and you also know angle B and Y are congruent, think back, we learned a theorem called third angles theorem. We would automatically know C and Z would have to be congruent too. And what that means when three angles of a triangle are congruent is that they're the same shape. Remember, similar shapes have the same angles. So just by knowing that two angles are congruent, that's enough to tell us that the two triangles are similar by angle-angle similarity. We don't even need the third pair because of third angles theorem. Next, let's talk about side-angle-side similarity theorem. So just like with side-angle-side congruence postulate, we have to have the angle pair between the two sides. So in this case, we have angle E and angle U are between the two pair of sides that we know are corresponding. Now, the lengths, it's a little different. The lengths this time are not congruent. However, they are the same ratio. They're proportional. So the lengths of two pairs of sides of one triangle are proportional to the lengths of two corresponding sides of another triangle, and the included angle, remember that's the angle between the two sides, are congruent. Then the triangles have to be similar by side angle side. So for example, on this one, you can see that these segments DE and TU, they have the lengths 5 and 2.5. If you think about that, 5 over 2.5, that's equal to 2 over 1. And then EF to UW, those are the lengths 2 to 1. They have the same ratio. Both of them are the ratio 2 over 1. So, since we have the same ratio for two pairs of corresponding sides, and the included angle is congruent to each other, we can conclude that these triangles are similar by side-angle-side similarity. Finally, we have the side-side-side similarity theorem. So this is a case where you don't know any of the angles, but the corresponding side lengths are all proportional. So for example, if you check this out, 4 over 12, 3 over 9, and 1 over 3, they are all the same ratio, 1 to 3. So that means that we can say these two triangles are similar by side-side-side similarity. Let's do some examples together. Determine if these triangles are similar. If so, write a similarity statement and justify your answer. So on this, I first right away notice that angle L and angle M are congruent to one another. I also notice that J and P are not congruent to one another. However, that does not necessarily mean that these are not similar. Let's see if we can find the measure of angle K. So remember, all three angles in a triangle must add up to 180. So if I take 180 minus the sum of 48 and 57, I will know the measure of angle K. So when I do that, I get 75 for the measure of angle K. And now I see that angle K and angle P are congruent. So now I can say triangle LJK is similar to triangle. Now be careful, just like with congruent triangles, we have to put these letters in a specific order. Angle L corresponds to angle M. Angle J corresponds to angle Q. Angle K corresponds to angle P. This is by angle-angle similarity. We had two pairs of congruent angles. Let's do another. So we have these two triangles, and I also see that these lines are parallel. So parallel lines, remember, create a lot of congruent angles. I would know that that angle, angle W, and angle R must be congruent. And also, if I look at the other transversal, angle T and angle X must be congruent. Another way you could look at this is the vertical angles, angle RSX and angle WST must be congruent because they're vertical. We only really need to write down two pairs, so let's go ahead and write angle T is congruent to angle X, and angle R is congruent to angle W because they're alternate interior angles. Then I can conclude triangle XRS is similar to triangle TWS by angle-angle similarity. Again, you could have used vertical angles here as well to get another pair of congruent angles. Let's check this one out. Now again, I immediately notice that angle C is congruent to angle D. Remember, all right angles are similar. However, this time, let's go ahead and find angle A. So the measure of angle A, I know that the acute angles in a right triangle always add up to 90 degrees. So if I take 90 degrees minus 44 degrees, that gives me 46 degrees for the measure of angle A. This time, I do not have two pairs of congruent angles. That means these are not similar triangles. They don't have the same angle measures. All right, let's try another one. I see parallel lines. I know that will give me congruent angles. Whenever you see parallel lines, that should help you think congruent angles are going to be somewhere. All right, remember, corresponding angles are congruent, so I know that pair would be the same. And if I look at another transversal, like this one, I know that the same reason, these are corresponding angles as well. The triangles that I'm looking at here are triangle LPQ and triangle JLK. I have two pairs of congruent angles so far, and if you wanted, there's actually another option. I also know angle L is congruent to itself because of the reflexive property. So I'm just going to use angle K is congruent to angle PQL because they're corresponding. So by corresponding angles postulate, I know that those are congruent. I could say angle L is congruent to angle L because of the reflexive property. And once you have two pairs of angles congruent, you can say the triangles are similar. So we'll say LPQ is similar to triangle LJK by angle-angle similarity postulate. So what we're going for here is either two pairs of congruent angles, that's what we've done so far, or sometimes you will know things about the sides. So let me show you this one. This one is a little different from the last because we do not have lines that are parallel here. They might be parallel, but we're not really sure. It doesn't tell us in the diagram. We can't just assume that they look parallel. So what we're going to do is we are going to look at these two triangles, AEF and ACB. Now, I know that AE is 8 and AF is 10. I need to find the length of AC and AB. This is pretty simple from chapter 1. 8 plus 4 gives me 12 for the length of AC, and 10 plus 5 gives me 15 for the length of AB. Now what I need to do is see if these triangles have the same proportion. So I'm guessing that probably AE probably corresponds to AC. So let's check this out. 8 over 12, what ratio is that? We can reduce it. They're both divisible by 4. That reduces to 2/3. Now I'm also going to guess that AF is corresponding to AB. So let's check that ratio. We have 10 over 15. They're both divisible by 5. That gives me 2/3 again. Make sure that you keep consistent. On this, I use the triangle AEF in the numerator, triangle AEC in the denominator, and I had to do the same thing when I'm checking my other proportion. Make sure you stay consistent. These have the same proportion, but that's not enough. I can use side, 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 or side, angle, side. Let's check out the angle between these two sides. Angle A is shared between both triangles. I know that angle A is always congruent to itself because of the reflexive property. So now that I have two pairs of sides that have the same ratio and the angle between them is congruent, I can say these triangles are similar. So I'll say EAF is similar to triangle CAB by side angle side similarity. All right, let's check this one. Now on this one, you do have some options. I know we could use an angle here that's congruent because they're vertical angles, but I want to go and do both examples for you. So I'll also show you when to use side, side, side. So this one we could do side, side, side because we have all three pairs of sides given to us. We need to check, are they the same proportion? So this, it's a little difficult, I know, but you kind of have to guess which are corresponding. I would guess that PQ corresponds to either TS or ST. I'm not sure whether Q corresponds to T or Q corresponds to S. But we can guess that. We can check it out in a minute. So 6 over 15, those are both divisible by 3. We get 2 over 5. Now, let's take a guess and say that QR corresponds to TR. So let's check that fraction. We have 5 over 12.5. Now, in order to see what that reduces to with that decimal, I would personally plug it into my calculator, 5 divided by 12.5, and then change it to a fraction. That's also equal to 2 over 5. So far I have both of them the same proportion. So that's good. Now I just need to check the last side. Is 8 over 20 the same fraction? They're both divisible by 4. And yes, it does also reduce to 2 over 5. I need you to make sure you're always using the same triangle in the numerator on every fraction. So notice PQR was in the numerator every time. Also, triangle TRS was in the denominator every time. If you change it up, it will not work. Since all three pairs of sides have the same ratio, I can say triangle PQR is similar to triangle STR. I had to make sure that those were in the right order by side, side, side similarity. Now another option for this, like I said, was to just use two pairs of sides and use the angle between them. If I was doing this, I would need to make sure that I use the pair of sides that give me the angle between the two sides. All right, last, let's check if this is similar. So I need to check these ratios. Again, this is kind of a toss-up to see which sides are corresponding. I would usually probably say to check the largest side with the largest side, the smallest side with the smallest side. Let's see what those ratios are. So we'll do triangle JKL in the numerator, and we'll try triangle PMQ in the denominator, and let's see what these ratios are. So JKL, we'll go with JK first, 16. I think that corresponds to PQ, which is 12. Those are both divisible by 4. It gives me 4/3. Now let's check the pink sides, LK and MP. So I have triangle JKL in the numerator, PMQ in the denominator. They're both divisible by 2. And that does give me the same ratio again. So I guess right so far, I think. Let's check this last pair of sides. So we have triangle JKL in the numerator, PMQ in the denominator. That is both divisible by 3. It gives me a fraction 4/3. And that's nice. They all have the same ratio, which means that the triangles are similar. So we'll say triangle JKL is similar to triangle. Now I need to be careful. J is between the blue and yellow side. Q is also between the blue and yellow side, so I know J corresponds to Q. K is between yellow and pink, so it must correspond to P. And finally, that leaves me L corresponding to M. I got this because I had 3 pairs of sides, all with the same ratio, so it's by side, side, side. All right, I want to know if you can explain this. Why is it sufficient to only show that 2 pairs of angles are congruent in order to show a pair of triangles are similar? Why does it seem like the third pair doesn't matter? See if you can remember back to what I said at the beginning of this video. All right, tomorrow we will work more on using similar triangles to solve problems. So we will be finding missing pieces, etc. See you then.